Hi, welcome to Online Lecture 4 on alkenes and alkynes. Here are the topics that we're going to cover today. So alkenes, as we covered in last week's online lecture, are essentially just hydrocarbons with double bonds. And so when we add a double bond, it actually changes the backbone from being just carbon-carbon single bonds to adding double bonds. So here is a good example where there's a backbone, and traditionally we would have classified the backbone as this. But now there's new rules that happen when we add double bonds to the mix. So with a double bond, the backbone is always the longest chain that includes the double bond. So that means that it's no longer the horizontal chain. We have to make sure we include the double bond there. So that means the root is going to be derived from this backbone, including the double bond. And then the name is just found by replacing ane with ene. So in this case, we have 1, 2, 3, 4, 5, 6 carbons long. And so instead of being hexane, the root is hexene. And how do we number a backbone that has a double bond on it? Now, instead of substituents, the double bond actually takes precedent in having the lowest possible index. So here's a good example. It's got a double bond on the largest chain, which is actually the 6-carbon ring. So the double bond and the substituent, we have to make sure that the double bond takes precedent. And so the way we number it, we basically have to start on one end of the double bond and include both carbons in the double bond. So in this case, it would be 1, 2, 3, 4, 5, 6. And the reason I didn't go the other way is because that would put the substituent, that ethyl, on carbon 5 if I had gone counterclockwise. And so because of that, I have to start down here on this carbon and go clockwise so that my first 2 carbons are 1 and 2 of the double bond. And so to name this, we start with the substituent for ethyl. And then the root is cyclohexene. Just like that. Now let's look at alkynes. They basically follow the same rule as alkenes, except now we're replacing ane with ine. So here are a couple of examples. So in the first example right here, it's a good example of how the triple bond will take precedent in the numbering over the substituents, because in the normal circumstance, we would start the numbering to the right on the bromines, but since we want the triple bond to be the lowest index, we start to the left. 1, 2, 3, 4, 5. And so because of that, we name it 5,5-dibromo for the 2 bromines. And then pent, because there are 5 carbons. And now here's the tricky part. In this case, the triple bond is on carbon number 2. Well, 2 and 3. We typically just specify the first carbon on the triple bond. And so in this case, we actually have to specify 2 ine, like that. Now, why did I not specify the index last time? Let me do this next example and maybe that'll be clear to you. So in this case, again, we want to make sure that the double bond takes precedent. So I'm going to start here. 1, 2, 3, 4, 5. Now notice, in the ring, I always put 1 on the double bond, or if it were a triple bond, I would always put 1 on the triple bond to give it the lowest possible index. In a straight chain, I don't have that option. I have to start at one end of the chain. And so there's no need to put 1 as the index in a ring because it's implied. And so this we can just write without putting the index of the double bond. We would just write 3,4 dimethyl cyclopentene. Like that. And because there's no index indicated here, it's assumed that it will be on 1. So what if we have a molecule that has multiple double or triple bonds in it? How do we name that? So if there are multiple double bonds, the ene is just preceded by the prefix indicated in the number. So just like we had dichloro or trichloro, we can have dienes or trienes. So if we look at this molecule, I see 3 double bonds. This is going to be a triene. So how do we name it? We have to pick the chain that contains all of the double bonds in it. And so it won't be the horizontal chain. It will be 1, 2, 3, 4, 5, 6, 7, like that. And so now we have that 7 carbon chain with 3 substituents coming off. So this is going to be a fairly long name. So we have nitro, we have propyl, because remember we only count the carbons off of the chain, we don't count the carbon on the chain, don't count that one. And then we have an ethyl up here. So remember, multiple substituents, you have to put them in alphabetical order in the name. So ethyl will come first. So we have 2-ethyl. And then we have 6-nitro, followed by 3-propyl. Now we're ready to do the root of this name. And so there's 7 carbons, so hept. Now we have to indicate the location. 1, 3, 5. That indicates the first carbon that each double bond touches. And then this will be called triene, because there are 3 double bonds in it. So that's the full name of that molecule. Let's try another one. Triple bonds are treated the same way as double bonds. So in this case, now we just have to pick the chain with the most triple bonds. So 1, 2, 3, 4, 5, 6, 7. So again, we have 7 carbons. And then we're dealing with 2 types of substituents, chlorine and methoxy. So chlorine comes first. So we have 7, 7 dichloro, because there are 2. And then we have 4 methoxy. And then the root is again hept, because there are 7 carbons. The triple bonds are on 1 and 5. And so this would be diene, like that. Now what if we have a mixture of double and triple bonds? Then we call it an ene, basically combining ene and ine together. And so here's a good example. We've got double and triple bonds. How do we number it? Well, do triple bonds take precedent over double bonds, or double bonds over triple bonds? That would determine whether or not we start from the left or the right. We actually give equal priority to double and triple bonds unless there's a tie. In that case, double bond takes priority over triple. So in this case, we start on the right because that double bond can be on 1. So again, we're looking at a 7 carbon chain. And so this would be 4-methyl for this one coming off the chain. And then we have hept for the number of carbons. And then we indicate the location of the double bonds first, so 1, 3. And because there are 2, we call it diene. And then the ine is on 5, and there's only 1. So N-ine can actually be split up if we have to indicate the location of those carbons.